You have been using databases for years. You type a query, rows come back, it just works. But here's the question almost no one asks. Where did those rows actually come from? Not the table, not the schema, I mean physically. What is database? When you strip away the magic. In the next 10 minutes, you are going to stop thinking of your database as a black box. You will see exactly what it is, what's inside it, and why it is built the way it is. And the next time someone asks you what is the database in an interview, you won't say a place to store data. You will have a real answer. Let's get into it. Here's the one sentence answer. A database is a program that organizes bytes on disk and gives you a query interface. That's it. That's the whole thing. Read it again. A database is a program that organizes bytes on disk and give you a query interface. A program that organizes byte on disk with a query interface on top. Let me break that down. It's a program, meaning Postgres, MySQL, MongoDB, SQLite, all of them, they are just software, code that runs on the server somewhere. Same as your app, nothing mystical. It organizes bytes on disk, meaning your data is just a bunch of files. If you look in the right folder on a Postgres server, you will find actual files with the name like 16384 or pg underscore wall. That's your data, bytes in a file. And it gives you a query interface, meaning instead of opening those files and reading raw byte yourself, you write SQL and the database does the dirty work. Stick this in your brain forever. A database is a smart file system with a polite front desk. That's it. That's all it ever was. The fancy feature, indexes, transaction, replications, they are all built on the top of that one idea. Now let me give you the picture that's going to stick. A database is a very organized library. Think about what a library actually is. There is a building. Inside the building there are the shelves. On the shelf there are books. The books are the data. The shelves are the storage. But library with just shelves is useless. If I walk in and ask for a specific book among a millions of books, am I supposed to check every shelf? No. So the real library has two more things. It has a card catalog. Remember those little drawers full of cards sorted alphabetically that tells you exactly which shelf a book is on. That's the index. And it has a librarian. You walk up to the desk, you say, I am looking for a book about database by a guy named ABC. The librarian doesn't go check every shelf. They check the catalog, walk straight to the right shelf and hand you the book. That's database word for word. The shelves are your disk files. The card catalog is your index, the B tree. The librarian is the query engine. The part that reads your SQL, figures out what you want, looks it up in the index and fetches the right bytes from the right file. You, the user, never touch the shelves. You never see the card catalog. You just walk up and ask. That's the entire point of a database. The query interface protects you from ever needing to know where the bytes actually live. There are three reasons you should care about understanding database at this level. Reason 1. Career. Every backend job interview will probe how deep your database knowledge goes. Knowing the rough shape of what's inside, even at this beginner level, separates you from people who can only describe what a database does from the outside. Reason 2. Debugging. The moment your queries get slow, you can't fix them without understanding what's actually happening under the hood. You need to know that pages exist, that indexes exist, that writing to disk is slow but appending to a log is fast. Otherwise, you are guessing. Reason 3. Design choices. There are dozens of databases out there. Postgres, MySQL, MongoDB, Redis, Cassandra, DynamoDB. They all do the same job. Organize bytes on disk, expose a query interface, but they make different trade-offs underneath. Once you understand the layers, you can actually pick the right one. Until then, you are just picking what your last team used. Okay, let's look inside. Here's what actually in there. A database has a 4 layer. from the outside in. The layer 1 is a query interface. This is what you talk to. You send SQL over a network connection. The database speaks back, sends you row. That's the front desk. Layer 2 is a query engine. This is the brain. When your query arrives, the engine has to do few things. It parses your SQL into tree. It plans how to execute it. Should it use an index, scan the whole table, join in this order or that order? It picks a plan it thinks is fastest. Then it runs the plan. Layer 3 is the storage engine. This is where the things get real. The storage engine is the part that actually knows how data is laid out on a disk. It deals in something called pages, fixed size chunk of bytes, usually 8 kilobytes each. Every table you have is a sequence of pages. Every index is also a sequence of pages organized into a B tree, so the query engine can binary search through millions of rows in a handful of steps. The storage engine also handles writes. When you insert a row, it doesn't just slap it on disk. It first writes to something called the write ahead log, a sequential file that records every change. Then later it updates the actual page. This is how database survives a crash. If the server dies mid-write, on restart it replaces the logs and reconstruct reality. Layer 4 is the disk itself. Real files on a real disk. If you have ever looked at the Postgres data directory, you have seen that. They are just files, nothing more. Open them in the hex editor and you will see bytes, not rows. The rows only exist because the storage engine knows how to interpret those bytes. So your one-line query goes down through these 4 layers. Interface receives it, engine plans it, storage finds the right pages, disk gives back the bytes, then it all flows back to the other way and you see rows on your screen. Every database on earth does roughly this. The difference are in the details. I want to be honest with you about something most courses won't tell you. The good news is databases are one of the most reliable pieces of software you will ever use. Decades of engineers have hardened them. They handle concurrency, crashes, replication and indexing better than anything you will ever build yourself. Use them, trust them. The bad news, they are not magic. Every database you use has a limits. Disk is slow, RAM is slow, network calls cost milliseconds. A bad query can bring down a perfectly healthy database in seconds. And here is the part that surprises new developers. You can absolutely outgrow a single database, not by writing bad code, just by having too many users. When not to use a traditional database? When your data has no structure and you are just dumping logs, a file might be enough. When you need a microsecond reads, a cache like Redis lives in memory, not on disk. Every component you add is the thing that can fail. Simplicity is a feature. 5 questions this video has already taught you to answer. Question 1. What is a database? In one sentence, a program that organizes bytes on disk and gives you a query interface. That answer alone will impress most interviewers because it shows you are not treating the database like a black box. Question 2. What are the layers inside a database? Query interface, query engine, storage engine, and the disk. Each layer has one job. The interface talks to client, the engine plans queries, the storage engine deals in pages and indexes, the disk just holds bytes. Question 3. What is the index reality? It's a separate data structure, usually a B tree that maps value to row location. It exists so the database doesn't have to scan every row to find one. Same job as a library card catalog. Question 4. What is a write ahead log and why does it exist? It's a sequential file the database writes to first before updating the actual data pages. It exists so the database can recover from crash by replaying the log. Question 5. Why are there so many different databases? Because they all make different trade-offs about what to optimize. Speed of read versus speed of write. Strict consistency versus availability. Structured data versus loose data. Same problem, different priorities. Master those 5 and you are already ahead of most candidates. Before you go, take 30 seconds to log this in. Takeaway 1. A database is a program. It organizes bytes on disk and gives you a query interface. That's the whole definition. Takeaway 2. Inside it has a 4-layer query interface, query engine, storage engine, and the disk. Every layer has one job and your query passes through all 4. Takeaway 3. The magic isn't magic. It's a library, shelves, card catalog, librarian. Once you see it that way, every database concept you will learn next clicks into place. In the next video, we are going to zoom in on layer 4, the disk itself. We will look at why disk is slow, why memory is fast, and why this single fact shaped every database decision ever made. If this helped you, hit subscribe so you don't miss the next one. The full playlist is linked below. See you in the next video.